In this video, I'm going to be introducing a triangle and talking about how we can classify different types of triangles. Let's start with the definition of a triangle. A triangle is a closed figure and it has three sides and three angles. We have different pieces or parts of a triangle. We have vertices, sides, and angles. The vertices are the corners of the triangle, and if I talk about them individually or singularly, we say vertex. So I have vertex A, vertex B, and vertex C. Because those are just single points, we describe them using a capital letter. Sides can be described a couple of different ways. We could talk about them as segments, or we could use a lowercase letter. So I could describe this side as segment AC or side B. I could describe this side as segment BC or side A, and I could describe this third side as segment AB or side C. If I talk about the measurements in between these two sides, I'm talking about the angles. So I have angle A, angle B, and angle C. And we'll talk about in later videos how those angles have to add up to 180 degrees in a triangle. Let's talk about how many different ways we can classify a triangle, or how many different triangles there are. We can classify them two different ways. We could just look at their sides and how their sides relate to each other, or we could look inside and look at their angles and see how their angles relate. There are three different ways we can classify triangles by sides. If all three sides are a different length, we call that triangle a scalene triangle. If we have two sides that measure the exact same length, we have what's called an isosceles triangle. And we symbolize side lengths being congruent or the same length by putting a little hash mark. And we put the same number of hash marks to symbolize which sides are congruent. So if I had another side that was different, I could put two hash marks there, or we could just not put anything. Over here on the scalene triangle, I could put one hash mark here, two hash marks here, and three hash marks here. So because I have different hash markings, I don't have any congruent sides. Or we could just simply not put anything there. If I have three congruent sides, I could put the same amount of hash marks. We could put one hash mark on each side, or we could put two. We could put more than that. That would just be a little silly. But if we have three side lengths that are measuring the exact same, we have what's called an equilateral triangle. So equa meaning the same or equal, and lateral meaning sides or measurements. So we have equally measured sides of a triangle. We have an equilateral triangle. If I look inside and I classify my triangles by angles, we have four different classifications. If all three of my angles measure less than 90 degrees, or if each of my angles are acute angles, I have what's called an acute triangle. If I have a right angle in my triangle, then I must have a right triangle. The other two angles actually have to be acute angles, and they have to be complements of each other. They have to add up to 90 so that I have 90 plus 90, giving me a total of 180 degrees in my triangle. If I have a big angle, an obtuse angle in my triangle, I must have an obtuse triangle. And the other two angles would have to be acute if I had an obtuse angle. If all three angles measure the exact same measurement, I have what's called an equiangular triangle. And we also know the measurements of each of those angles. If I know that my total has to be 180 and I divide it equally into three measurements, 180 divided by 3 gives me 60. So I know that each of these angles measures exactly 60 degrees in an equiangular triangle. It's also important to note that the equilateral triangle and the equiangular triangle are the same triangle. If I have side lengths that are equal, across from them must be equal angles. We'll learn that in a later video. So if I have three equal sides, I must have three equal angles. I must have an equiangular triangle and an equilateral triangle, and they must be the same. So let's see if we can use that information to classify triangles if we're given it, or if we're given the description, can we sketch one out? So here we're given this triangle and asked to classify it. We got to classify it based on our sides and our angles together. So because I have two equal sides, I have an isosceles triangle. And because I have a right angle, I have a right triangle. So together they create an isosceles right triangle or an isosceles right triangle. If I'm told that I have a triangle that's acute in scaling, can we sketch it? Well, if it's an acute triangle, I must create a triangle with all acute angles or angles measuring less than 90. And because it's scaling, I can't let any of my sides be equal lengths either. So I could either not put any hash marks, because that would symbolize that none of them are equal, or I could put different hash marks symbolizing that none of them are equal. So there's how we classify triangles. 7 different types based on angles or by sides. And then when we name them, we got to name them by using classifications from these two lists. So we got to classify them by both sides and angles.